Lesson 5-3, Adding and Subtracting Mixed Numbers. The main idea of this lesson is to be able to add and subtract a mixed number. And remember, a mixed number is a fraction with a whole number in front of it, like this. So this is a mixed number, so the types of problems that we're going to be doing today are adding and subtracting when we have mixed numbers like this in them. Here's our first example. So we're going to be adding. And the very first thing I do when I'm going to be adding fractions is I look at the denominators. And if the denominators are the same, then I'm all set. I don't have to worry about changing so I have a common denominator. Most of the hard work is already done for you. So that means that we can just go ahead, since we're adding, we can go ahead and we can add the whole numbers together. So 7 plus 10 is 17. And we can go ahead and we can add the numerators together. And 4 plus 2 is 6. And then remember, you don't add the denominator together. The denominator is 9, so we're just going to bring that down. Now we have to take a look at this and make sure that the fraction is in simplest form. So we have to figure out, is there some number that can go into both 6 and 9? Well, 3 can go into both 6 and 9. The whole number part's going to stay the same. So how many times does 3 go into 6? It goes in twice. And how many times does 3 go into 9? It goes in 3 times. So when you're adding mixed numbers like this, you can add the whole numbers together, and then you add the numerators together, and then since we already have the same denominator of 9, we just bring that down, and then we simplify. Let's take a look at a subtraction problem. Here, when I take a look at this, the very first thing that I notice is my denominator over here is 6, and the denominator over here is 3. So that means we need to find a common denominator. In other words, we need to find some number that both 6 and 3 can go into. And remember, it has to be as big as the biggest number or bigger. Remember, when you find a common denominator, you don't have to worry about finding the smallest one. You don't have to worry about finding the least common denominator. You just need to make sure that you find a number that both of the denominators can go into. So when I look at this, I notice that 3 can go into 6. So that means that 6 is a common denominator for these two fractions. So that means this first fraction is going to stay the same. I'm going to just write 8 and 5/6. You're going to bring the subtraction sign down. We're not going to do anything to the whole number. We're just going to bring that down. And now I'm going to take a look at this and ask myself, okay, what do I have to multiply 3 by in order to get to 6? You have to multiply 3 times 2. So remember, if you multiply the denominator by 2, you also have to multiply the numerator by 2. So that means our new fraction will be 1 times 2 is 2, and 3 times 2 is 6. Now when I look at this, I need to make sure that, can I really subtract 8 minus 2? Yes, I can. I can do that and get a positive number, and I can go 5 minus 2, and I'm going to get a positive number. So everything is all set for us to subtract here. 8 minus 2 is 4. 5 minus 2 is 3. And we're just going to bring the 6 down. Now we have to look at this and figure out, is it in simplest form? No, it's not. What can go into both 3 and 6? Well, 3 can go into both of them. So that means in simplest form, 3 goes into 3 once, and 3 goes into 6 twice. So our answer is 4 1/2. So we changed the second fraction so that it had the common denominator of 6, and then we subtracted the whole numbers from each other, and then we subtracted the numerators from each other, and we brought the denominator down. Let's take a look at another example. Here we have 2 1/3 minus 1 2/3. So what I've done here is I've drawn out what does 2 1/3 represent. Here I have one rectangle. Here I have the other rectangle. So these two rectangles right here are equal to the 2. And then I made a third rectangle, but I only colored in 1/3 of it. So this over here represents 2 1/3. And over here, this represents 2 2/3. Oops, I gotta color in a little bit more of this. There we go. So now I have 1 and 2/3. And I'm going to take these two, I'm going to subtract this from this. I'm going to take this away from over here. So what's going to happen is I'm going to subtract this one here from this one over here. They're gone. But here, I can't just take 2/3 away from here because this is one whole rectangle. So what you have to do is you have to borrow. I have to take this rectangle up here and I have to cut it into thirds so that I can take 2/3 of it away. So now that I've cut it into 2/3 and I know how much is 2/3, now I can take that away. I'm going to take it away from this side, and I'm going to take it away from this side. And what do we end up being left with? I have 1/3 here and 1/3 here, and those two 1/3 pieces together make 2/3. Okay, so we don't want to have to draw it out every single time, do we? How can we do it without drawing it out? Well, here's what you can do. Here's how I knew I was going to have to cut this second piece over here into thirds and borrow. When I look at this, I know that I can subtract the 2 minus the 1, and I'm going to get 1. But my problem arises when I try to go 1 minus 2. Yes, you can do that, but you're going to get a negative answer. You can't have a positive whole number and a negative numerator. That doesn't work. So what you have to do is you have to end up borrowing from this number right here and putting it in the numerator. So in other words, I'm going to change this 2/3 into 1, and then I'm going to take those 3 pieces that I cut here and I'm going to add it to this part down here. So remember, I had 1, 2, 3 pieces here plus this 1 extra third right here. That makes 4 1/3 pieces. So that means I have 4 pieces that were cut into thirds. Now I'm going to bring that fraction down, and now look, I can go 1 minus 1 is 0. There isn't going to be a whole number here. And then I can go 4 minus 2 is going to be 2, and my denominator is going to be thirds. So you see how that works? I had to borrow right here. I had to borrow from the whole number, and I had to put those 3 extra pieces. I knew there were going to be 3 because the denominator is 3. I add those 3 pieces to the 1 that I already have in the numerator to make 4 2/3. And then you just end up subtracting like you normally do. Let's take a look at one last example. Here we have 8, and we're going to take away from it 3 3/4. So I've already modeled this for us. What most students will do is they'll go, oh, 8 minus 3 is 5, and then they're just going to stick the 3/4 on the end. Let me give you a hint. That is not the answer. We can't just do that. We have to do that borrowing thing, right? So here's what I'm going to do. Another way for me to write 8 and have the common denominator 4 is I could represent this as it's 8 whole pieces with 0 pieces that are cut into fourths, right? Because I don't have any pieces down here that are cut into fourths like this is over here. And then over here we have 3 3/4, and we're trying to subtract these two things. So here's what I'm going to do. I'm going to take this, before I get to that, I can't go 0 minus 3, so I have to borrow. So what I'm going to do is I'm going to take this last rectangle down here and I'm going to cut it into fourths. So that means I have 1, 2, 3, 4, 5, 6, 7 whole pieces now. I have 7 whole pieces, and I have 4 pieces that are cut into fourths, right? Remember, 4 over 4 is the same as 1. Here we have 1, 2, 3, 4 pieces that are cut into fourths, and that's a whole rectangle. So here's that extra piece that we needed in order to make the 8. So here we have 7 whole pieces and 4 pieces that are cut into fourths. Now I can subtract. Because 7 minus 3 is going to be a positive number, and 4 minus 3 is going to be a positive number. So now it's going to work, whereas before it wasn't going to work. 7 minus 3 is 4, and 4 minus 3 is 1. And then you're going to bring the denominator of 4 right across. And that's our answer, 4 1/4. And I showed you how I ended up borrowing and how I cut this last piece and turned it into fourths and changed this from an 8 to a 7. And that's all there is to subtracting mixed numbers. Just make sure when you subtract that when you subtract your whole numbers, you get a positive number, and when you subtract your numerators, you get a whole number. And if one of them doesn't come out to be a positive number, sorry, I didn't mean to say whole number. When one of them works out to be a negative number, that means you have to borrow. When one is positive and one is negative, that's when you have to borrow. Other than that, you should be all set.